Welcome to this class, and today we'll be looking at a topic in physics under this branch, thermal physics, which is called heat or thermodynamics. Now, the first aspect of thermodynamics cut across many subtopics such as temperature and its measurement, such as expansion, etc. So, the first aspect we'll be looking at is first, what is heat? Heat is a form of energy that causes the sensation of warmth. And under this, we have subtopics such as temperature and its measurement. What is temperature? So the first thing we're looking at here is temperature. Temperature is the degree of hotness or coldness of a body, and it is a measure of the average kinetic energy present in the body. It is the degree of hotness or coldness of the body and a measure of the average kinetic energy present in the body. And temperature can be measured using an appliance or an apparatus called thermometer. This thermometer is the apparatus that we use for measuring temperature. And we have different types of thermometer. We have what is called the clinical thermometer. We have the laboratory thermometer. And the difference between the two of them is that the clinical thermometer has a constriction compared to the laboratory thermometer. Then temperature can be measured using different units, but the SI unit, which is standard international unit of temperature, is the Kelvin. Kelvin is the SI unit because it has absolute zero temperature of minus 273 degree Kelvin. And we have other scales of temperature such as the Celsius scale, we have the Rankine scale, and we have the Fahrenheit scale, apart from what? The Kelvin scale. And there's a difference between their conversion rate. For example, if I have 0 degrees Celsius, so this is just a table showing their different temperatures. So here we have 100 degrees Celsius, and here we have 0 degrees Celsius. At that same conversion rate, on the Kelvin scale, here we have 273 Kelvin, here we have 373 Kelvin. And this is Kelvin. Then we have the Fahrenheit scale. Fahrenheit scale, where you have 212 Fahrenheit, and here you have 32 Fahrenheit. So all of these are the different scales of temperature. And how do you calculate or convert from one scale to another? You convert from one scale to another using their fundamental interval. The fundamental interval is just the difference between the highest temperature, which is the upper limit, and the lower limit. And here, the same thing here, this is the upper limit and this is the lower limit. So the difference between these two here is the fundamental interval for each of these temperature scales. So if you are converting from Celsius to Kelvin, for example, it means you have to equate the fundamental interval here to the fundamental interval here to what? Calculate. You have something that looks like this. You'll be having Celsius minus Celsius at 0 over Celsius at 100 minus Celsius at 0 to be equals to Fahrenheit minus Fahrenheit at 0 over Fahrenheit at 100 minus Fahrenheit at 0. So this is the conversion formula for each one of them, and that is how you do it for every single one of them. Moving on. So apart from all of these, we also have the Rankine scale, like I told you before, but the Rankine scale has gone into obscurity because it is hardly used. Okay, moving on, we have what is called heat transfer. That is under subtopic under the topic thermal physics or heat thermodynamics. So heat transfer, this is just the movement of heat from one region to another. Is the transfer due to what? Temperature differences. You will notice that when you walk into a very cold room like an AC feed room, when you walk into that room, if you are coming from a hot environment, you mainly walk into that room. After some time, you discover that you start catching cold, or your temperature will drop as a result of what? Heat that has been absorbed from your body as a result of the cold room. So heat has left your body, it has transferred from your body down to the room, which is colder, hence you are feeling colder at that particular time. So heat transfer is just the energy transmission due to what? Temperature differences. And heat can be transferred using many methods or different methods. One of the ways that heat is transferred is conduction. The other method of transfer of heat is convection, and the last method is radiation. Now, the first one, which is what? Conduction. This is the transfer of heat in solids as a result of what? Temperature differences, and these solids must be in contact. So, for heat to be transferred via conduction, there must be what? Contact. An example of such method of transfer of heat is your method of cooking. So, your pots are directly in contact with the fire, hence, whatever is inside the pot gets heated up via what? Contact. So, likewise, your convection is just what? Heat transfer in fluid. And heat transfer in fluid involves heat transfer in liquid and gases. So, your conduction talks about what? Transfer through what? Liquid and gases. And it is what? Done through what? Movement of the particles. As the particles are constantly moving and colliding, there is what? Transfer of heat, and that is what? Convection. The next method of heat transfer is radiation. Radiation is the transfer of heat through a vacuum using electromagnetic rays or electromagnetic wave. And one of the methods or one of the examples of such heat transfer is the transfer of heat from the sun to earth. So the method by which you can feel the effect of the sun on earth is called what? Radiation. That is the method of transferring heat from the sun down to the earth. So these are the three methods of what? Heat transfer, and that is heat transfer. So moving on, thermal expansion. So expansion is simply the increase in size of a body. It has to do with increase in length, increase in area, or increase in the volume of a body. So hence, thermal expansion is caused by heat. So expansion ordinarily is talking about what? Increase in size. But thermal expansion is talking about increase in size as a result of heat. So when substances are heated, they expand. This occurs in solid, it occurs in liquid, and occurs in gases. So expansion in liquids, when they expand in liquid, is different from when they expand in gases, is different from when it expands in solids. So thermal expansion or expansivity. Thermal expansion is also called expansivity, and it is the increase in length, area, or volume of a body with a degree rise in temperature. Now, moving on to the types or forms of expansivity, we have what is called the linear expansion, which is also called linear expansivity. We have the superficial expansion, which is also called area expansivity or area expansion. We have the cubic expansivity, which is also called volume expansion or volume expansivity. So the first one, which is linear expansion, this is the increase in length per unit length per degree rise in temperature. What does this mean? It means for every amount of the length that is added, every increase in the length of the body, you are relating it with what? The temperature increase. So by how much is the temperature increase to cause that what? Increase in length. So linear expansivity, we denote it with alpha, and it is what? Increase in. So we have increase in length, that's change in length, all over length, change in temperature, which is also the same as saying final length minus initial length, all over initial length, final temperature minus initial temperature. So this is what? Linear expansivity or linear expansion. We also have what is called area expansion or superficial expansion or superficial expansivity. We denote it with beta. We denote that with beta, and it is increase in area, change in area, all over area, change in temperature, which is the same as saying that I have final area minus initial area, all over initial area, then final temperature minus initial temperature. We denote it with beta. Then we have the last one, which is what? Volume expansion or volumetric expansion, which is also called cubic expansivity or cubic expansion. This is increase in volume, and is what? We denote it with gamma, and it is change in volume, all over volume, change in temperature, which is the same as saying final volume minus initial volume, all over initial volume, final temperature minus initial temperature. So these are the what? The different forms of thermal expansion. But there's a relationship. There's a relationship between these three forms of expansion or expansivity. There's a relationship between this, which says that my superficial expansivity, or you can say your area expansivity, which is beta here, is equal to 2 alpha. And my cubic expansivity is equal to 3 alpha. So this is the relationship binding your different forms or types of expansion. Now, these expansions can be applied in railway lines. So when you see where they build the railway, discover that there's a gap in between the rails, and the essence of that gap is to allow for expansion during hot weathers, so that when there is expansion, it can easily fill up the gap. But if gaps are not left, it could lead to accidents on the road. Likewise, bridges, when bridges are constructed, also leave gaps, and the gap there is for expansion. So those are the real life applications, and we also apply them in thermometers. So moving on, that takes us to the laws of thermodynamics. Thermodynamics has 3 laws. The first law of thermodynamics is called the law of conservation, and it simply says that energy can neither be created nor destroyed, but can be transformed from one form to another. That's the simplest law, and it is talking about how energy is conserved, meaning that you do not used up energy only, that energy is just transferred. You are not just destroying the energy. So when you eat your food and then you have chemical energy, the chemical energy is converted to other forms of energy, and you decide to run. When you run and then you are feeling hungry, it is not because your energy has been used up only. It has been transformed to the form of energy that you use for running, and heat has been generated. So hence that energy has now moved to another form. So we have it in different forms just like that. You can have other examples, transfer of energy from electrical energy to heat energy, like in your electric ions. So that is what the first law of thermodynamics is saying. And you have a formula that says the quantity of heat is directly is equal to your change in U plus the watt, or the work done in that particular energy. So this is the formula for the first law of thermodynamics. What is the second law of thermodynamics saying? Second law of thermodynamics says that heat naturally flows from a hot body to a cold body. Heat naturally flows from a hot body to a cold body. What does this mean? That unless there is work done, that heat on its own naturally flows from a hot body to a cold body, meaning that the body that is losing heat is the hot body. The hot body has to lose heat to the cold body, and the cold body has to absorb the heat in order to become hot. So that is how it naturally flows in life, and that is the second law of thermodynamics, and that is what it's talking about. So if you try heating up a body, or you bring 2 bodies together and one of them is hot, the other one is cold, and they come in contact, you discover that the cold body will become warmer, and the hot body will lose some of its hotness. That's because heat has transferred from the hot body to the cold body. That's what the second law of thermodynamics is saying. So moving on to the third law. The third law of thermodynamics says that as temperature approaches absolute zero, the entropy of a perfect crystal is 0. What is this saying? That immediately you discover that if you have a perfect crystal, that once that perfect crystal start approaching absolute zero is that temperature where you have minus 273 Kelvin. At minus 273 Kelvin, you discover that the entropy is the degree of disorderliness of a body, how scattered the body is. So the degree of disorderliness of a body mainly start approaching this temperature, you discover that it will become 0. So your change in entropy at that particular time will become 0. Okay, that's what heat engines. What are heat engines? These are engines that will convert heat. So engines that convert heat energy into mechanical work, they are called what? Heat engines. So example is your engines in your car. So when your cars, you pour your petrol inside and then you discover that what? When you start the car, the ignition of the car, there is smoke coming out from the exhaust of the car. And you're wondering, I did not light fire inside the car. Immediately you turn on the ignition, there's a spark from the spark plug in the car that will what? Ignite. So that there's constant burning within the engine. And that burning within the engine generates heat. It is that heat that allows your car to move. So it is that heat that is not transmitted to what? Mechanical energy. So it is that heat that allows the car to move. So automatically that makes your what? Your car engine to be what? A heat engine, because it is converting heat energy into what? Mechanical work. So it's using what? Your heat energy to do what? Mechanical work. What are the basic parts? We have the heat source, we have the working substance, and we have the sink. These are the basic parts of a heat engine. And what is the efficiency? You can calculate efficiency normally is usually what? Work output all over work input times 100 over 1. And because it's a machine also, heat engines are generally machines, it will have the same what? Formula for calculating its efficiency. So, like I said before, one of the examples is your what? Car engine. But please note that no machine is 100% efficient. Why? Because some of the heat, some of the energy that is present in that machine will be lost in the process of conversion. It will be lost what? To heat. So some of the energy is what? Lost according to the what? Second law of thermodynamics that we stated earlier. So let's have some questions based on this. So the first question here says, what is the SI unit of temperature? Like I said before, the SI unit of temperature is the Kelvin. SI then means what? Standard international. So the standard international units of temperature is Kelvin. Despite the fact that your Fahrenheit and your Celsius are also what? Scales of temperature, they are not the SI unit. The SI unit is what? Standard international unit, which is what? Kelvin. That is what? Option B. Question number 2 says, heat flows from a hot body to a cold body. From a hot body to a cold body, according to the what? Second law of thermodynamics. That is what? Option B. Moving on. Question number 3 says, which method of heat transfer does not require a medium? I explained that earlier, and I said that the method of heat transfer that does not require a medium because it travels through a vacuum is what? Radiation. Radiation, it travels through a vacuum, travels through space. So it does not require direct contact. So that is what? Radiation. That is option C. Question number 4 says, thermal expansion occurs when dash. So thermal expansion occurs when a substance is heated. So for there to be expansion, heat must be involved. I said earlier that what? Thermal then means what? Heat. Expansion is on its own talking about what? Increase. So thermal expansion occurs when what? A substance is heated. So that is what? Option B. Question number 5 says, the first law of thermodynamics is based on conservation of energy. Conservation of energy. Please, it is not conservation of momentum or conservation of heat or conservation of mass. It is what? Conservation of energy. That energy can neither be destroyed nor created, but transformed from one form to another. So that is option D. So that is also question number 6, which says, which of these best describe conduction? Like we said before, conduction is the transfer of heat from within solid, and it has to do with what? Bodies in contact. So let's look at our option. Option A says transfer through fluid. Wrong. Transfer via direct contact in solids, transfer through waves, and transfer in vacuum. The correct option is B. Transfer via direct contact in solid. So that is option B. So that is also question number 7, which says, a rise in temperature increase. A rise in temperature increases dash. a rise in temperature increases the kinetic energy of particles. So whenever you increase the temperature of a body, the particles within that body will start vibrating at higher energy rates. So they will start moving faster. So a rise in temperature increases the kinetic energy of particles. That is what? Option C. Moving on to question number 8, it says the second law of thermodynamics states that what? So we talked about what? The second law of thermodynamics that talks about what? The flow of heat from a hot body to a cold body. So this second law of thermodynamics talks about what? Heat flows naturally from hot to cold body. That naturally heat only moves from hot to cold body. And that is what? Option C. So that is the question number 9. Which says, which of the following expands the most on heating? Which of the following expands the most on heating? Now, when you heat up solids and when you heat up liquid, or likewise when you heat up gases, they do not expand the same way. Gases expand more, and the reason is because they have free mobile particles already, unlike solids that are closely packed or liquid that are taking the shape of this container. Gases are free mobile. Their particles are already in excited state. So heating it up makes it more excited. So it expands a lot more than solids and liquid. So the particle that expand the most on heating are what? Gases. That's what? Option C. Moving on to question number 10. It says, in which process does heat transfer occur due to bulk movement? Bulk movement. Now, the process by the method where bulk movement occurs in heat transfer is in convection. In convection, the particles of the liquid or fluid move in bulk. So bulk movement only occurs in convection, and that is what? Option C. So moving on to question number 11, it says, heat energy converts dash. So your heat energy, like we said before, it converts what? Heat energy to mechanical work. So it converts heat energy into mechanical work, and that is what? Option C. So that is the question number 12, which says efficiency of a heat engine is always dash. Now, I said something earlier, and I said that the efficiency of a machine is hardly 100%. It cannot be 100%. So the efficiency of a heat engine, which is a machine, is always less than 100. It is not 100, it is not more than 100, it is not 0, it is less than 100%. So that is what? Option C. So that is the question number 13, which says, what property of matter makes thermal expansion possible? What property of matter makes thermal expansion possible? The property of matter that makes thermal expansion possible is not magnetism, it is not compressibility, it is not viscosity. Instead, it is kinetic energy of the particle. Like I said before, that when you increase the heat, the kinetic energy of the particles also increases. So it is the kinetic energy of the particles that makes what? Thermal expansion possible, and that is option C. So question number 14, it says, which law explains why no heat engine is 100% efficient? That is the second law of thermodynamics that talks about what? The natural transfer of heat from a hot body to a cold body, and when that happens, there is what? Heat loss. That is the second law of thermodynamics, and that is what? Option C. So that is the question number 15, which says the temperature at which a substance has no kinetic energy. The temperature at which a substance has no kinetic energy is the absolute zero temperature, and that is what? 0 degree Kelvin. At 0 Kelvin, that is what? Option D, which is also the same as saying what? Minus 273 degrees Celsius. So what you have here is 273 degrees Celsius, not minus. So this is what? Option D, which is what? 0 degree Kelvin. So that is what? Option D. So moving on to question number 16. It says, radiation differs from conduction and convection because option A says it is slower, option B says it only occurs in solid, Option C says it requires a medium, and option D says it does not require a medium. So we explained earlier that for conduction to occur, that what the substance has to be in contact, and for convection to occur, it has to what be between particles of fluid, and those particles are what constantly in motion. So they have what is called bulk movement. So, but radiation occurs without any medium. So there is no medium as it is using what electromagnetic waves. So the difference between radiation and the other two is what it does not require a medium, and that is what option D. Moving on to question number 17, it says, which of these is not a method of heat transfer? Which of these is not a method of heat transfer? So looking at this, now we talked about three methods of heat transfer. We talked about conduction, convection, and radiation. But here we are having option A says conduction, option B says compression, option C says convection, and option D says radiation. And the question is, which of these is not a method of heat transfer? So the correct answer is what? Compression. Compression is not a method of heat transfer. So B, option B is the correct answer. So that takes us to question number 18, which says, a device that uses heat to do work is called dash. A device that uses heat to do work is called a heat engine that uses what? Heat energy to do mechanical work. So it converts heat energy to do what? Mechanical work, and it's called what? Heat engine. So it is not a refrigerator, it is not a conductor, it is not a thermostat, but what? Heat engine, which is what? Option C. So that is also question number 19, which says, when a metal rod is heated, it expands due to dash. Option A says it expands due to increase in particle energy, decrease in particle energy. Option B says increase in particle mass. Option C says increase in kinetic energy, and option D says chemical reaction. Now we talked about expansion. That expansion occurs as a result of what? Increase in kinetic energy of a body. So for a metal rod to expand when it is heated, it has to be what? As a result of increase in the kinetic energy of the metal rod. So the correct answer here is what? Option C. So that is also question number 20, which says, in the first law of thermodynamics, what does W represent? In the first law of thermodynamics that we had earlier, where we talked about that thermodynamics is changing U plus W. And in that formula, what they're asking us is, what does that W in that formula represent? That W in that formula represents the work done. So the work done is what? W in that formula. It is not weight, it is not watt, it is not wavelength. It is what? The work done. Thank you for staying with us till this time. See you in the next class.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 type of different exams, including JAMB, WAEC, Cacao, NET, IELT, and the likes like that. Also, in every video you watch, we have the link to our apps where you can download on Google Play Store and Apple Play Store and practice hundreds of past questions for free.